Hello and welcome to the presentation on error handling mechanisms in programming. In this session, we will explore types of errors, exceptions, and how error recovery works in programming languages like Java, Python, and C++. Let's dive in. Error handling is a crucial aspect of any programming language. It allows developers to anticipate and manage issues that may arise during the execution of their code. In this presentation, we will focus on different types of errors, how exceptions are handled, and how to propagate and recover from errors. We will look at examples in Java, Python, and C++. Errors can be categorized into three main types: syntax errors, runtime errors, and logical errors. Syntax errors occur when the code does not follow the correct language rules, such as missing semicolons or misspelled keywords. These errors prevent the program from compiling. Runtime errors occur during the program's execution, like division by zero or null pointer exceptions. These errors cause the program to crash if not handled properly. Finally, logical errors do not stop the program but result in incorrect behavior, like producing wrong output due to a flawed algorithm or condition. Exceptions are used to handle runtime errors in a more structured way. When an error occurs, an exception is thrown, and the program can catch it and respond appropriately. In Java, for example, we would use a try-catch block to catch exceptions. The try block contains the code that may cause an exception, and the catch block handles it. This ensures that your program continues running smoothly even if an error occurs. Sometimes you need to ensure that certain code is executed regardless of whether an exception occurs or not. This is where the finally block comes in. It is used for cleanup actions like closing files or releasing resources. Even if an exception is thrown, the finally block will execute, ensuring proper resource management. In some cases, you may want to handle different types of exceptions in one block. You can do this by catching multiple exceptions using separate except clauses or a single except clause with multiple exception types. This approach makes your error handling more concise and organized. Error propagation refers to how an exception moves up the call stack when it is not caught at the current level. It continues to propagate until it is either caught or reaches the top of the stack, causing the program to terminate. Error recovery is a mechanism through which the program can continue running after an error. This can involve retrying operations, using fallback strategies, or presenting meaningful error messages to the user. Let's look at an example in Java. If we try to open a file that does not exist, a file not found exception will be thrown. We handle this by using a try catch block. In the catch block, we can print a message to inform the user that about the missing file, ensuring the program does not crash. In Python, error handling is very similar. We can catch exceptions like value error or zero division error using multiple except blocks. This allows us to handle different types of exceptions in a structured way, making our code more resilient to errors. In C++, exception handling works with try-catch blocks as well. If an error is encountered, such as trying to divide by zero, an exception can be thrown. We catch the exception in the catch block and display an appropriate message to the user. This prevents the program from crashing unexpectedly. In conclusion, error handling is an essential practice in software development. It not only helps catch and fix errors, but also ensures that your application runs smoothly even when something goes wrong. By using exceptions, try-catch blocks, and other mechanisms, developers can create more robust and user-friendly applications. Thank you for your attention. Now I would like to open the floor for any questions you might have. Feel free to ask anything about error handling, exceptions, or any of the concepts discussed today.